right. Hello, good morning, good afternoon, good evening, everyone. How are you all doing?
Doing great.
Yeah, going
How's-
well.
Awesome. How's your weekend, Akansha?
It's going like it's the start of the week, so a lot of workload.
Oh yeah. No, I hear you. I hear you. Dan, what about you? How you been?
Yeah, good. Some downtime before chaos resumes. We are 2 weeks out from KubeCon, so
Oh yeah, that's right. I saw that you're doing a SIG bouldering. Is that
the SIG
true?
bouldering.
Oh.
Yeah. I'll also actually be doing a talk about Cilium as well on the
Nice.
Wednesday. So
Nice.
sharing that with Nico, which I'm super excited about.
That's
Like
fantastic.
SIG bouldering is happening for the first time.
I say that again, sorry.
The SIG bouldering thing is happening for the first time.
SIG bouldering is a funny one. I'm going completely off topic here, but SIG bouldering is it happens at quite a lot of the KubeCons, and various people over the years have kind of organized it. So, kind of originally it was organized by Chris Nova, and people like Josh Russo and others would kind of be part of it. And yeah, I've been kind of running with it for like kind of the last 4 KubeCons or so, I think. So.
Okay.
Yes, there's been SIG bouldering in Chicago. There's been SIG bouldering in Detroit. In what was the last European one? Was it wasn't Barcelona? Was it? It was
Amsterdam.
There you go. Yeah.
Awesome. Yeah, no, that'd be fun. Yeah, share those details when you can. I'll pass it along to some folks that might be very interested in bouldering. I know some folks that got into it very recently and would love to show off some of their climbing skills.
Their moves.
Yeah. So I have some news to share. Some exciting news. The last couple of years, I've spent time in the DevRel space, jumping around, going to conferences, talking about different thought process around networking, around Kubernetes, around service mesh. And I tend to do this a lot, where I tend to bounce back and forth between a few different roles. And I'm actually starting a new role today. I'm actually starting as a solutions engineer at Commodore. So I'm going to be focusing in on a lot of operations, optimization, security, basically platform engineering. And it's really cool because, networking's been the biggest thing for me for the longest time. And moving into this role, I still get to do a little bit of that. But it's a larger focus. It's a much broader focus, which kind of takes me back to some of my VMware Tanzu days. So I'm very, very excited. And the best part is I get to continue this momentum with Cilium, with the weekly learning networking with Cilium. So I'm excited. I'm excited for us to just continue this stuff. So
yeah, absolutely. Congratulations.
Thank you. Yeah, I'm very excited for myself. It's interesting because I start today, but I had everything all like ready to go. I just got my new MacBook and my trackpad and all that fun stuff. So it's like today is all set up, and then the first thing I have to do is like a Cilium stream. So it's fun. Anyways, this stream actually is very relevant to the stuff that I'm going to be doing anyways, because it's all about observability. And in my networking days, one of the biggest assets that we had were these tools that told us what was going on in the network. It would tell us, the path between two endpoints. It would tell us the behaviors. It would tell us about latency. And the reality, though, is that all of these tools were multiple tools. So you couldn't simply aggregate all this data and create some mindset or some strategy around how does this all make sense and make sense of it all, right? Now you've got like log data that you got to pair with it. Mm-hmm. So we've come a long way, right? We, in the cloud native world, with especially Cilium, there are observability tools, but specifically Hubble, right? And Hubble's been that de facto standard for the last, how many years? A couple of years now?
4 years, I'd say.
That's awesome.
Yeah.
So yeah, I want to explore Hubble. I know, Dan, you've got not that much time because you got to bounce.
I grant all the 10 minutes, unfortunately.
Okay, so let me pass it to you. You've got 4 minutes to explain Hubble, its key details, and I'll take us to the lab environment right after you're done.
Sure, yeah. I suppose it's kind of funny. I'm intrigued what Marino back in the day, as it were, was kind of using for his networking observability. For from my perspective, kind of everything was built upon SNMP and kind of like things like MRCG, which was traffic generator. Oh, I can't remember what it was actually called. It'd be on Wikipedia, but yeah, like this is what everybody basically used to monitor how much traffic was flowing around in their networks and stuff like that. So Hubble, Hubble is this almost not talked about enough part of the Cilium stack. And most people deploy Cilium, they have Cilium set up, and it's basically auto-magically managing packets going from pod to pod and pod to service and out the box through host networking, load balance, and all that sort of jazz. All powered by eBPF. Everything's all powered by eBPF in the Cilium world. So because we're sat there on the data plane, you're kind of moving all these packets around, and we're also in the Kubernetes control plane, we can marry these two things up. And that effectively what Hubble is kind of doing. Hubble is both a CLI and a UI. There's a Hubble controller, which obviously does the logic side of things. But effectively, it's using a combination of like eBPF programs to see where traffic is actually going, and then marrying that up to what's actually happening on the Kubernetes API server, and presents us with a fantastic way of being able to view not only traffic from source to destination, but traffic from, when I say source to destination, most people will normally think of two IP addresses, so the source and destination IP address and endpoint, and the ports therein and things like that. We can marry that up to the actual source and destination from a logical standpoint within the Kubernetes cluster. So that would be the outside world coming into a service, then from that service going to the pods that sit underneath. And we get basically, this fantastic overview of your architecture from the networking services, pod architecture, and things like that. What's even more cool, really, is not only do you get, either from the CLI or UI, this fantastic architectural overview of how everything all hangs together. But if you're using things like network policies, which we covered in amazing detail last week, and somebody were to try and access a service that was trying to access some pods, we would actually be told, if the connection wasn't actually working, the Hubble UX would effectively say traffic can't go there because there is a verdict of deny, which effectively means, Hubble is telling you that one of your network policies is sat within the traffic path and effectively either allowing or dropping that traffic to it. So it's such a fantastic Swiss Army tool for that observability piece into understanding your architecture and things like that. And as I mentioned, as part of the Cilium stack, if you haven't got it installed and you require it, it's effectively a case of using the Cilium CLI and doing set Hubble.enabled equals true. That's it. That will add a bit more manifest to your Kubernetes cluster. Your controllers will start running. You can then use the CLI to immediately interact with that, start printing out, to your terminal what's actually happening. It's an additional Helm flag to enable the Hubble UI, and then you expose that through a port or change it to a load balancer or whatever you want to do. You can then hit that, and you can actually see everything that's actually happening within your cluster. So that is Hubble. As I say, it's kind of always there. It's just not a lot of people know, or in my opinion, at least, not enough people know about it, and I think more people should. So I'm super happy to see people talking about it.
Awesome. Love it. Love it. Just want to say a few hellos. Hello, Rahul. Thanks for coming by. Anais, thanks for coming by as well. And then Krish, thank you for coming by. Welcome. And then Siddhant, yes, hello. We will definitely talk about eBPF someday. Actually, this is where we'll definitely need Dan, because Dan's the expert here.
I mean, the biggest worry there is how deep a deep dive, because it can go hella deep.
Yeah, I mean, I don't think we'd be getting to the level of building eBPF based programs, but I think understanding the differences of like a ring buffer versus a hash map, and then how that data gets stored, how that data gets pulled from kernel and stored into user space. That kind of stuff is relevant because in the world of eBPF, it's all about events, right? Something happens, a trigger happens, and that causes something else to occur. But we could definitely dig into that later on.
Yeah.
Dan, any final words before you have to drop?
No, not hugely. As I say, we focus largely on Hubble providing that kind of observability piece. It sits on top of Cilium. So Cilium is what powers a lot of the data that is feeding into the Hubble UX and things like that. Kind of marrying alongside that really is also Tetragon, which is kind of, we're talking about observability, but kind of enforcement of behaviors and things like that. Tetragon also sits on top of what Cilium's actually doing. So it kind of, that's what allows us to marry up policies and enforcement to what Cilium's actually doing as well. So Cilium is basically the base layer of all of the kind of logic that's actually happening with packets and things kind of moving around. We kind of, pair Hubble on top of all of that in conjunction with the API server to give us that deep observability that's Kubernetes aware. Kind of Tetragon from an enforcement perspective. But I'm a huge fan of Hubble. And I always love, especially at KubeCon, when so I'm usually sat on the Cilium booth all day, every day. When we get Hubble up and people who've not necessarily seen it before suddenly kind of get this big visual overview of the architecture of kind of the network services inside of a cluster. It's like that. Where have you been hiding this?
I love it. Okay, cool. Let's get into some of that hands-on action. All right, let me pull up the lab environment. And this time I'm actually using a lab environment that is by Isovalent. So how I got here, actually, let's go over here and look up Isovalent lab. Sorry, I misspelled Academy, but head over here and
might need to swap screen. There you go.
There we go.
Yeah.
So now you should be able to see my lab screen, but you see like there's so many different kinds of labs you can take. And from my understanding, there are also tracks here. So depending on the kind of role that you currently have or that you're working towards, there are tracks that can help you get there. So I love that.
And not forgetting all the badges as well. So like, if you wanted to put kind of all of the your LinkedIn and stuff like that, you can earn a zillion badges. And there's a big handwave from Raphael, who's in the chat at the moment. He is the creator of many of these amazing labs as well. So
interesting. Okay. Shout out to Raphael. Thank you so much. It's interesting as I'm going through some of these different labs, I'm seeing the one for multicast and I'm like, multicast,
that's new.
It's new, but it's also like, there's like a gap between when I actually learned about it, had to need to use it, and then all of a sudden it just enters the chat all over again. So I'd love to go back and explore that at some point. But there's so many others that you can take. Go check it out. They even have ones around mutual authentication, service mesh, some of the gateway API stuff. Cool stuff. All right, let's get into the lab, and then y'all can go and explore that stuff later on. Okay. So it's telling us to look at this lab environment, and it's saying that we have a cluster already running. So let's see what we have. Get nodes-oy. So we have a 3-node cluster, or 2-node cluster, I should say. And I'll remove the OY. If it's a little too small, I'll make it a little bit bigger. The problem is I have to, there we go. Okay, that looks a little better. 2 nodes, and then we'll just do a kubectl get pods-a. I just want to see what's already installed. So Hubble, seems like Hubble is there. It seems like Cilium is already ready to go.
I do profusely apologize. Poor planning on my part, but I will try and return as soon as possible.
No worries. All good. And yes, shout out to Nico as well. Nico had a huge hand in the creation of some of these labs as well. Nico is also a network engineer, much like me. So a lot of those networky things that you see, like BGP, multicast, I'm sure he had a massive hand in. Now, all right, let's go back here, and it's going to tell us in the node section, you can see that the cluster consists of 2 nodes, a control plane, and a worker. Usually the control plane is where we don't deploy workloads. It's the worker node is where we actually deploy real production workloads or any kind of workload. And the reason why this is because we want to create some separation or distribution with the way we handle our control plane and our data plane and even management plane. Because if one piece fails, like we don't want other pieces to fail too. For example, if I lose my control plane, even if I didn't have new pods being scheduled here, the ones that are currently scheduled on kind worker should continue to run until there's, a timeout or, there hasn't been an update in a while. Now, we are exposing the ports on the control plane node so that we can access them from the work machine. Port 31234 used to access the Hubble relay from the CLI, and port 31235 is used to access the Hubble UI.
So you're using the Hubble UI or the CLI?
I am not sure. I mean, maybe this lab will guide us towards either or. I think it's nice to be able to see either or. The UI is nice just to be, I've seen it before. It's just nice to be able to visualize our traffic flows and whatnot. But I'm not sure how much control is in the UI. I haven't tested it out myself, so we'll find out today. I imagine the CLI, we have complete control, so I can't imagine we lose anything. All right. And then it says here, note that since the standard port for the Hubble relay is 4245, we have exported the Hubble server variable into the current shell to use 31234 port instead. Okay, let's run the code. Okay, so localhost 31234. Nice. In the networking section of the configuration file, the default CNI has been disabled, so the cluster won't have any pod networking when it starts. Instead, Cilium is being deployed to the cluster to provide this functionality. So we've already checked it out. Because Cilium is running, and also because core DNS is running, right? I know that Cilium is functional, so we have a working environment here. So let's move on to the next section because I have no idea what's in the next few sections. But what we can see here is we're going to deploy a demo app. We're going to observe. Okay, so we're going to observe network flows using the Hubble UI. And then there's some other stuff here around identity, DNS, HTTP, and then the timescape.
Oh, these sections, like this challenge is like really nice if somebody wants to start. So completely.
Yeah, I think it's a great way, like for folks to even learn.
And it's also free, right?
Yeah, it's free. I mean, free is a point of view because if you have to give up your email address, then I don't consider that free because now you're taking up real estate in my mailbox. All right, so now we're going to deploy the demo. So it's telling us, let's start by deploying the simple demo application that we can use to explore Isovalent Enterprise for Cilium connectivity. So let's go ahead and just play this. And it's using a Helm chart to go ahead and deploy something called Jobs app. And it's been deployed. And it's saying this application installs into the tenant jobs namespace and is made up of 11 services which emulate a job application website. To imitate human interaction, one of the services called Crawler is included, which accesses and pushes files mimicking a user uploading their CV or their resume. Throughout the lab, we're going to delve into the intricacies of the application's microservices and do the traffic flow analysis with Hubble. So that's pretty cool. So let's go ahead and run. Hold on. While the application is starting, let's check if Cilium has been successfully deployed. Yeah. We want to make sure that everything looks good. And to me, everything does look good. So Cilium is good. The operator is good. Envoy is not running, which means that the service mesh functionality isn't on. And then Hubble relay is turned on.
So everything looks fine.
Yeah. And then we could go on to run Hubble status to see what's going on. And it's telling us that it's okay. It's telling us how many flows are going on and how many flows per second and how many nodes are part of the Hubble environment, which is 2, which is basically our control plane and our worker node. So we're going to list the nodes and it tells us what
all are connected and working. Yeah, I was just saying that all are connected and working.
Yeah. So this is what Hubble is seeing. Now we're going to check the application itself. So let's list the namespaces. So if you're taking the CKA, kubectl get ns is the short form of get namespaces. Another nice command to know, show labels, in case you needed to find out which namespaces had labels associated to them. Now, the one we care about is tenant jobs. So we're going to do kubectl get pods -n tenant jobs. And it tells us that there are a number of pods running, but some are not. So you can launch the command multiple times to ensure all pods are running. I'm not sure why not all of them are. I mean, it's probably taking its time, so that's okay. And I think we do have Leon. I'm not sure if I can add him to the stage because I don't see him on camera yet. Leon, you there? There we go. Hello. Welcome.
Yeah, hi. Sorry, I'm late.
No.
It's all on you now. Now you gotta finish it all off. You gotta finish off the rest of the line. No. You missed the announcement.
That's mad.
Oh, what is it? The job?
I can't. Yeah, I can't tell you now. It's too late. You'll have to go back and watch the replay. You'll have to wait till the end.
That's okay.
All right. Let's double check and see if the pods are running. Okay, now everything looks good. So it took a bit of time. Maybe this was intentional. Maybe the pods actually were just really huge container images. So all the pods are running. Let's go ahead and check and see if everything's good. While everything clears up here, Leon, how was your weekend? Leon,
you want?
I don't think so. I got a weekend.
Oh, I apologize if you didn't get a weekend.
Just been doing other stuff. So I prep for a talk and also,
I know the drill. All right, so we've got the demo application, and it's going to allow us to see something like this. I like this. This is nice. All right, so let's see. Let's start. All right, the Hubble CLI connects to the Hubble relay component in the cluster and retrieves logs called flows. This command line tool provides the ability to easily visualize and filter the network flows, significantly enhancing your Kubernetes network troubleshooting capabilities. For example, you can see the latest flows linked to the tenant jobs namespace with Hubble Observe tenant jobs. Okay, so I butchered that. Ooh, gosh, this is fun. So Hubble Observe -- namespace tenant jobs. So it's telling us we'll see a timestamp, we'll see the source pod, we'll see the direction of flow. Oh, that's cool. A destination pod, a trace observation point, a verdict, and a protocol. So now I'm going to stop for a second here, right? If any of you are familiar with like OpenFlow or SFlow or like even Wireshark, right? Wireshark presents very similar information. It's presenting you with a source, a destination, a direction. It's presenting you with ports and the type of traffic. And this is exactly what Hubble is doing for us. Now, we could pick on any one of these lines, right? Like we could even look at the first line. It's giving us a date. Here's the, I guess this is the destination because of the direction of flow. And this is the direction it's going towards this on this port. It's telling us that it was forwarded. Yeah. And it's like, it's so nice that it even breaks down the TCP SYN ACK as well. And that's important because it also tells us which one of these flows is a TCP flow versus a UDP flow. Now, if you look at a UDP flow, there's no acknowledgement. And in fact, it even says like the verdict here might be denied. We don't know why. I have no idea why. There might be a policy in place here that we haven't even checked. But this is cool.
And so like, what is the trace observation point?
So let's look at that. The trace observation point here.
It's down. Yeah.
So 2 endpoint, 2 stack, 2 overlay. So the trace observation point, the endpoint I imagine is going to just another endpoint, like another pod. The stack, I'm actually not sure. So it says here there was one that said to stack. To stack, TCP stack maybe the host level stack. This is something we'd probably want to research. And then there's another one to overlay. Now to overlay, I would imagine it's talking about node to node. Oh, Dan came back. This is excellent. All right, Dan, question for you, right? And this is a question from Akansha. Welcome back. That meeting was quick.
That was a very quick meeting, yeah.
Hope it was a good meeting. Productive, quick meeting. I love quick, productive meetings. Anyways, trace point when we're looking at these different log flows. Now, trace observation point. To endpoint, I would assume is a pod, right? And then to stack and to overlay, I'm not sure what these are. Maybe could you tell us, or maybe do you know off the top of your head?
Not off the top of my head. I can only imagine to overlay is effectively to the overlay network itself as to where
like to VXLAN if we're going to another node or something, right? Yeah. That makes sense. It's something we could look into. Or Kantra, if you want to research it maybe and look into it, and then we could highlight it in a second. But maybe also you could help us understand this flow as well, Dan. So I've got a date here. I've got a destination, I assume, because of the direction of the traffic. And it's saying tenant jobs, job app entity operator, and I'm assuming this is a pod on this port, which is interesting to me because wouldn't this be the one talking to this? Because it looks like the direction is the other way, which actually makes sense because this could just be an acknowledgement of the receipt of traffic.
I mean, given the TCP flags that it's actually sending as well, it looks like this is effectively ending, given it's got the thin flag. It's
okay. So this makes sense about the I guess the output of the logs is it's going from like oldest to newest is probably why. Okay. That makes sense now.
So what we're seeing here is connections that are being established. So we're actually seeing A trying to speak to B, whether A, and then we can see, that here one of them is this operator that's actually running within the cluster, and we can see how far it actually got in terms of there was an acknowledgement of connection, then the connection was actually finished and things like that. So we can see the flags that define how the connection's actually, or the state of connection.
Well, that's awesome. Okay.
One additional thing, which is also kind of important, is it's purple in color, but it's the ID number. And those are IDs that Cilium applies to
endpoints.
Yeah.
Okay. Endpoint IDs. Okay. So this is a CLI view. Let's look at the Hubble UI view. So we could go over here. And we can go to the Flows tab, and then we can choose a namespace. We can choose the tenant jobs namespace. Oh, look at that. Look at that. That's beautiful. So we've got the entity operator, and it's got these two services, I guess.
Yeah, if you click on them, it breaks down kind of all of the labels and things like that you can see attached to them, which should tell you what it actually is.
Oh, wow. Okay, so we've got Zookeeper. So this is in a sense somewhat like Kiali. Have you ever heard of Kiali before? I think we talked about it at one point, maybe. So Kiali is like the layer 7 view of the flows. So if we were doing like pod to pod traffic, the thing that it would abstract is from a service standpoint how that flow works. So this is interesting. So if I pick on any one of these, oh wow, okay, so it's just the log that we saw, except now it's much more visualized. So we've got a source pod, a source ID, the labels, the destination that we're going to. Oh wow, this is so cool. So it's very, very thorough. Like it's very specific about all of these different flows here.
Yep. Yeah. And as I was mentioning, the fact that you get like this visual overview of the architecture, like, you know, because I mean, if you try to do this from the CLI, just kind of doing kubectl gets this, that, and the other, it's very hard for you to actually work out the architecture from doing these sorts of things. You can sit and read labels, and you can sit and look at selectors, and you can, with a notepad and pen, do this, but it's going to take quite some effort to actually work out what is allowed to and what should be speaking to what and things like that.
Okay, so this is like what we're looking at is a service map, effectively, according to this lab environment. So yeah, so the service map is just service to service interaction here, with all the stops in between. So let's proceed and take a look at some of these flow lists as well. There's the policy section here. I won't touch it yet. I'll maybe save that for you when we get a little bit further towards this end of this. So in the Hubble UI tab, we are presented with the enterprise UI. We can display the service map of the tenant jobs namespace. And then at the bottom, we see the flows. Oh, there's a dropped flow here. Oh, there's a policy. Okay, so interesting. So we're seeing all of the flows that have been forwarded with the exception of one, which was dropped. And if we click on the dropped one, we're basically going from crawler to loader. It was dropped because of a policy. Wait, so if I click review, policy denied, but I can't review the policy. Interesting. So maybe it's under here. Oh, there we go. Nice, nice. Okay, so it's actually telling us of a policy here. I'm going to try and like make this as big as I possibly can so we can see. This looks very similar to Network Policy Editor.
I wouldn't be that surprised if that's almost the same code.
It is like, it looks so similar. So this is the policy, and what it says is, ooh, this is not that good. Let me see if I can. Okay. So we have a policy. It's called Jobs App Network Policy Zookeeper. The pod selector is the Stringy Job App Zookeeper label. It's an ingress policy from this label to this port or this port TCP. And then it's going towards the cluster operator on this port right here. So the interesting thing is there's a policy that allows this, but the crawler is not allowed because the crawler doesn't have this label. Let's look at the crawler identity for a second here. Yeah, it doesn't have that. Okay, so if you look here, it doesn't have this label. So because it doesn't have this label, it's obviously going to be blocked. Am I right?
That's for ingress, isn't it? So
and then if I look at the source pod here, I don't see anything that matches that.
yeah, so the Strimzy label is missing from it.
Yeah. All right. So it's aggregate flows. We kind of already saw that. Identities versus IP addresses. Yeah. Why don't you tell us a little bit about identities versus IP addresses? Like, why don't we just use IPs? What's the problem with using just IPs?
Yeah, so I mean, the reason for not choosing IPs really is for us to have something that is a little bit more. We want to be able to have some instances where IP addresses may change, but still apply. Even though the IP address has changed, we still know kind of where that traffic is coming from, or the application may have still run, but the IP address underlying it is changed, or Things have moved around from one node to another. It has been given a new IP, but the identity still remains the same. We apply policies based upon that identity. So effectively allows us another way of ensuring that we know how we apply our rule sets to things that are actually happening within the cluster itself.
Mm-hmm.
And we use those Cilium IDs. We can then use that ID to look up its updated IP address and things like that. We can use that ID to determine whether the traffic should be encrypted. We can use that to determine whether the traffic is allowed through policies. It's effectively what binds the rules within Cilium to what's actually happening based upon things like a pod and things like that.
Okay, so this is interesting because, like, if I really wanted to go ahead and update this policy, I could. It's not something I'd want to do here, obviously, because the real process is to review all changes in production. But it would be as simple as I could take this app equals crawler and add it into here as well.
Yes, yeah.
And then that would just address the policy. The other option is I could actually take this label and drop it into the deployment spec of this workload or directly on the pod itself. And then that should technically also address that. But then that also creates more of a situation where you're doing it on offhanded or one hand, like one off.
Because I mean, you'd have the wrong job with the wrong name. And at that point, you'd have Zookeeper attached to a different job just to ensure that rules were allowed.
Exactly. All right. So there are a couple of other questions. Go ahead.
No. You've got IP versus identity. That's all. You've got actual what we were talking about.
Yeah. Awesome. All right. So Raphael is confirming that it is network policy editor code. Love it. And it's included in the Enterprise Edition interface, I imagine. And then Mark, welcome, Mark. Mark's asking, does Hubble UI support external authentication? And I'm already assuming I can understand why, because he wants to somehow partner and do some open unison magic there, which is totally cool. And Raphael's like, yeah, it does in Isovalent Enterprise, not in Hubble OSS version though. All right. Okay, so we've talked about IP versus identity, and then we want to do DNS visibility. So before we start digging into it, what is DNS visibility? Like, what is this? Why is this important?
Yeah, I mean, it's the same reason, we kind of talked about this a little bit with the policy perspective and things like that, but it's effectively saying what can and can't go and speak through to DNS. It's understanding entities based upon DNS names versus things like IP addresses, and a lot of things typically within the Kubernetes cluster will sit underneath a DNS name, as opposed to, I've never really liked the term pets versus cattle, but it's that sort of thing. We don't really want to be emboldened to a particular IP address, so we tend to basically hide things under DNS to allow that flexibility for things.
Mm-hmm. Okay, so let me read through this quickly and then see what we're trying to do here. So actually, I also want to see where we are.
Yeah.
DNS visibility, HTTP visibility, and timescape. Okay. So if we notice in the Hubble UI service map that the crawler identity makes HTTPS requests to the world identity, but there's no way to know which actual DNS names are used. And we can also see this in the terminal. So if we run this, we'll see an output similar to this right here. This is what we're talking about, this particular line. Okay. And now in order to inspect DNS lookups for pods within the namespace, we must apply a network policy that tells Cilium to inspect port 53 traffic from pods to kubedns at layer 7. So to apply a policy, we have a policy. Let's first verify that we get the same type of information using the Hubble CLI. So what does the Hubble CLI tell us? Nothing.
So yeah, this is effectively, if we look in the output here, we can see we've got kube system core DNS, but underneath that, we've got a bunch of IP addresses that we're hitting.
Yeah, exactly.
We basically want to take this to the next level and have it do DNS lookups as it's, or using eBPF under the covers, we're going to find out what's actually being resolved to and what we're actually looking at here.
All right, let's go ahead and apply this policy. Oh, there's a warning here. This simple visibility policy works for this scenario when we are not trying to implement a zero trust networking policy or, a default denial. This is a DNS visibility.yaml policy should not be used in combination with other egress network policies, as it will allow all egress connectivity. You can view this policy spec with the command. All right. So egress to all entities, to endpoints, match labels, kube system, and then kube DNS to port 53, protocol any. Match pattern is, a wildcard. Perfect. So this is all described here as well, if you want to read further. So what does the Hubble UI or CLI tell us? So let's copy this command because I don't even know what this command is. Hubble observe -- namespace space tenant -jobs -- protocol DNS. So we're just looking for DNS based flows at this point. Okay.
Cool.
So now we have DNS observability at this point.
Yeah. So we're effectively, we have the capability of looking into DNS requests that are taking place and actually pulling out that information so we can present that through Hubble.
So if I do a refresh here, we should be able to see DNS-based requests as well, right? Somewhere.
Yeah. So we can see these now. If we went back to the crawler,
it's resolving.
In the destination, we can see like loader, which is another pod with the service. But we can also see that it's going out. It's going to the outside world. We can see that in the UI now. It's a little world icon on api.github.com.
Exactly. That's nice. Okay. All right. So now we're going to enable HTTP request views in the flows. So let's go ahead and get to that. So why would we want to enable HTTP views in Hubble? What is the importance or significance of something like that?
I mean, again, this is making things more application aware. Being able to see things like DNS names means that we know, for instance, if something is hitting a server that, an easy example is if I install something and all of a sudden I can see it going to bitcoin.com or whatever, and I can resolve all of that, I know that something is doing something Bitcoiny within my cluster, and I immediately get that observability of knowing that I'm hitting sites that I shouldn't necessarily be hitting, for instance. And it's kind of the same with HTTP. So knowing, kind of paths that are actually being accessed. So, am I hitting /admin on something, or it's just kind of more observability into what the applications are actually doing, or what we're actually accessing externally as well. So we get just a lot more in-depth knowledge of the places that we're accessing and also what we're trying to do when we access those places. So we get just a lot more detail in terms of what our applications are actually doing internally and to the outside world as well.
That's pretty awesome. All right. Now what we have to do here in Hubble is like what we're seeing here is based off of core API. I don't see any HTTP data. I just see layer 4 data and protocol information. But if we want to enable that, then we'll go over to the terminal and we have to apply a specific network policy to make that possible. And so even if I ran this command protocol HTTP, it's not going to output any HTTP information or data. So let's go ahead and apply this policy. And let's also see what the policy is saying to us. So endpoint selectors, any from all entities to port specifically 80, 80, 80, 90, 80, 50,051, and 9200, which are all TCP-based ports. And then there is a set for rules for HTTP, which is just empty. So this is, I guess, is that a denial almost?
I'm not 100% what the HTTP specific rules would be in there. Does it say from entities to ports to capture them? I can scroll down a little bit more. Okay, from Raphael. We're cheating here because we've got Raphael in the background.
That's allowing all this traffic. Okay. Got it. Got it. Easy answer. Thank you, Raphael, for that. Okay. So we've got the policy applied. We've seen the policy that's there. Now, if we check the Hubble CLI, we should be able to see. So it's not a zero trust approach, correct? Yeah, because we've pretty much opened up a lot. Let's go ahead and see the HTTP. Oh, here we go. So now the requests that are going through, look, we've got one going to Elasticsearch, which is a local service. We're seeing posts to Core API, to Loader. Oh, this is awesome.
Yeah,
that's awesome. Okay, so we can see a lot. We can see all the HTTP flows that are coming in. And in fact, we can even filter on method, which is interesting. So I can do based off of delete, post, push, or patch, I should say. So what did I select? I select based off of applicants. Let's try this other one. Based off of post, those are all the flows with post methods. Oops, dang it. I didn't mean to do that. Actually, you can't see that. Let's try delete. I just want to see if anything comes up with delete. Nothing. So let me add Leon back into the stage. Welcome, Leon. So this allows us to now effectively see all the flows from an HTTP lens, which is cool because this is getting very, very close to Kiali at this point. Kiali would do the exact same thing, which would visualize the HTTP flows between the different services. So let's go back to the Hubble UI now. Let's do a quick refresh here. And if I click on, once the data loads, if I click on crawler, I can see there's an HTTP request here. And we can see all the HTTP information.
Yeah.
Love it. Love it. Okay. That is awesome. That is awesome. All right. We've got HTTP visibility, and we're going to check out Timescape. All right. Let's go check out Timescape. And then we will get close to getting towards the end. All right. And then Raphael said, we do have other labs focused on using network policies for zero trust. Absolutely. Go check that out. Okay. I hope this is not a long one. Okay, this is not. Now we have enabled the Timescape feature as part of the Hubble Enterprise for this lab. So we're in the Hubble UI. So we can see a bunch of different things like the ClickHouse operator, the default names. These are all the different namespaces. Yep. What's this live view that I'm seeing here? Let's select the tenant jobs namespace, right? And then we've got live view enabled. Oh, actually, if we disable this, okay, wow. We can modify this a little. Actually, we don't have a lot of data. This has only been around for like an hour. Yeah. But that's okay. Like, this is beautiful because it tells us what's been gone on for the last hour. I wish I could, I could do this on a per 5-minute basis too. Oh, nice. So you can narrow it down, and I'm sure like, you know, if you ask the nice folks over at ISOVail, they could even give you timers and tuners down to the second if you wanted, maybe, or maybe you could hack away at it yourself. Who knows? But that data might be very powerful if you're, you know, in the high frequency trading environments, where there's a lot of transactions going on consistently. So I like this. This is very, very powerful. So it's telling us during the lab walkthrough, you may have noticed that some of the flows from crawler were dropped but subsequently allowed as you move through the challenges in the lab. We could try to retrieve those flows if we go to the terminal and see what those flows look like. There's nothing there. I'm not sure what it's trying to do for us. So it's telling us to expose the Hubble timescape service, and then we can use the Hubble CLI to connect to the timescape to pull the same historical data. Oh, this is just telling us to do this through the CLI.
Mm-hmm.
Okay. Well, I don't think I can do this when I have this running. Oh, there we go. Oh, okay. So it's telling us the dropped denied packets. I love this.
Yeah.
So while we were seeing this from the Hubble UI, where we could see crawler being dropped, well, it doesn't show all the ones being dropped, but let's do the last hour. Oh, wait. Why are they not showing the ones being dropped? Am I missing something?
Was it crawler? Can you go back to the terminal?
Crawler. Oh, wow. You can even narrow this down even more if you wanted to. Basically, what you're doing in the UI, you could just do in the CLI. So I guess for folks that are that are watching in, there are two ways to visualize how your data is flowing between your services. Obviously, I much prefer something that's visual, but the output of the Hubble CLI actually is very powerful, especially if you're trying to feed that into some sort of, I don't know, machine learning system that helps you determine some of your historics around your network heuristics for that matter, that help you discern patterns around, how much data is leaving at a given time, right? Or why that's happening, or who's actually doing this. This is great. Like in case you had a developer or you had an operator that accidentally pulled a malicious container into your environment that started causing denial of service attacks. I'm going to add 30 minutes, although I don't need to. But because of that, we now effectively have this capability that tells us, okay, if we're not looking at this from a layer 4 standpoint, but we want to see this at layer 7, we might be able to indicate if there is some sort of denial of service attack going on. Maybe there is an attack going on based off of user. What's the HTTP header? Is it user application or user something? Can't remember what it is. But user data. So you can specify header data, user data, that at the TCP UDP level, we wouldn't be able to detect or determine or discern. But you could only discern that if you had something like Hubble that would understand this at the HTTP layer. So this is why this tool is extremely powerful. Heck, I think all network engineers should start looking into it. My question to you, Dan, is does Hubble extend outside of Cilium? Can we look at other network devices and network endpoints as well and try and understand what's going on, or are we not there yet?
So Hubble itself is pretty much Kubernetes specific. It requires being able to speak to the API server to understand the identities and things like that. It also has a large dependency on Cilium in order to have some of those eBPF maps in place and pull out that information so that it can kind of visualize all of that. Tetragon is based upon Cilium, and it uses Cilium for a lot of things, but you can actually use Tetragon without Cilium to do some sort of similar sorts of things where you can kind of extrapolate information out based upon other eBPF programs that aren't necessarily using Cilium itself. So there's overlap, and so Hubble is basically almost a one-to-one relationship with Cilium. Tetragon can use Cilium. It can also run outside of it. It can also run outside of a Kubernetes cluster as well.
Awesome, cool. So there you have it, folks. We just saw Hubble in action. So if we wanted to start making policies, because I remember we talked about this last time, would Hubble be the right tool to do that, or would that be Tetragon?
So, as we kind of demonstrated a little bit with, I've put in there's another chat, but there's basically a cheat sheet for Hubble which has all of the CLI command line things for getting more information out and things like that. But for enforcing policy in terms of, there's two sides to it really. But yes, you can use things like policy editor. You can use a policy editor inside of Hubble. It's the same policy editor that's on networkpolicy.io. But you can apply those policy and immediately see in the UX, whether that's the CLI or the UI, what's actually happening and things like that. With Tetragon, you can apply policies that are external to the kind of Kubernetes cluster itself. So this effectively would be a policy that's IP address specific, or would almost be more like a firewall rule that's being enforced by eBPF programs that attach to things like XTP and TC and things like that, or have rules based upon sockets and things like that. So Tetragon can apply rules that are Kubernetes specific, but it can also be completely external and apply rules to just general behaviors that would happen within a Linux kernel itself.
Awesome.
So you've got two options basically.
That's fantastic. Okay. I mean, I think we are out of time, so I think we should definitely come back and explore some more of this. Possibly we'll do some Tetragon if you've got the time next week. Can we do Tetragon next week?
I can't do Tetragon because I unfortunately will be snowboarding next week. However, I'm
good.
certain I can find somebody who will be more than happy to talk about Tetragon with you.
If you could send Christine or Nico or whoever, let's go. Just ping us. We'll make it happen. All right. Yeah. You know what? If not, I can go a different direction. No biggie.
No, I mean, Tetragon as well, a little bit like Hubble. It's grown and grown and grown, and it sits upon the things that we did in Cilium, but we've kind of found use cases outside of Kubernetes. So we've kind of done that sort of thing. It can pull all of that Cilium information and use all of that. But it's one of those products that's just kind of projects even that's just kind of found more use cases as we've been kind of adding features to it and things like that. And I mean, the roadmap for that is just huge because it's kind of just growing and growing. And we're creating more eBPF programs that plug into various parts of the kernel. So we can enforce what can and can't run. We can enforce what files can and can't be read. We can enforce what can connect to what, and kind of look into kind of the layer 7 side of things, a little bit like we showed today, but outside of the dependencies of Kubernetes and stuff like that as well.
I love it. All right. Well, I just want to say thank you all again. Thank you, Leon, Akansha, Dan, for coming by, hanging out, learning networking in public with Cilium and Hubble today. We will see you all next week, and we will dig into Tetragon. So we hope to see you all there. Thank you all for your time. Have a great morning, evening, afternoon, the rest of your week. We will see you all. Take care. Bye.
Cool. Thanks.